Greetings, humans! This is Yamato, Vergil's sword from Devil May Cry 5. In this video I will show you how to print it and assemble into an awesome prop. Let's start with printing. We have here a lot of tall, thin objects, and if we just print them on our build plate like it is, even with a wide brim and great bed adhesion, we will have a problem like this, where at the start we have a pretty consistent surface, and closer to the top the quality drops significantly. To print this kind of part successfully, we need additional support structures. I made them looking kinda like this. And when using those structures, the parts come out a lot more uniform from top to bottom. Similar kind of support structures are also required for scabbard pieces. Even though they are not that thin, they still need to be quite smooth. Support structures for the scabbard will leave some marks like that. For me, it's not a big deal, because I usually sand, prime and paint my props, but if you want to print without them, it's still possible and it will give, I think, an okay result. In the original source material, scabbard is not smooth like that. It has some kind of texture on it. The texture is pretty generic, it's not something particular, and I've tried to use fuzzy skin to make something that looks similar. This, I think, looks closer to the original, but both of them are looking great. You can easily paint areas that you want with fuzzy skin in your slicer. I use Orca Slicer and it's like 2 clicks there. To use custom supports, import the part together with corresponding support file. When Slicer asks if it's a single object, you should press yes, because if you press no, parts may assume incorrect position relative to each other. Then right-click and split two objects, so I can control settings of each part separately. For example, configuring seam placement. Also, for the support object, I will reduce the number of walls to 2 and remove the infill. Also increase the speed. I designed the gap between parts so that I could break the support structure away when it's printed. This gap is very small, and if on your printer the support structure is welded to the part too hard, you can increase this gap right here inside the slicer. I will go back to the individual settings of the support structure. Under the Quality tab, there is an XY contour compensation. I advise to use small increments like 0.01 mm, but I will set a larger value for demonstration. There is also a gap between the part and the brim, and it can also be broken away. This setup works great for tall parts. I just wished I could use less plastic, but it is what it is. If you haven't used fuzzy skin before, this is how to set it up. I need to split the parts to objects again, so I can edit only the scabbard part. After I designated where I want fuzzy skin to be, I need to enable it in the settings for this particular object. Those are the values that I chose, but feel free to play with the numbers. All of the small decorative pieces, for example, like this one, like this one, or like this small dragon under the wrappings. It's called Minuki. All of those parts I printed on a resin printer. But I have also tested every single part using a standard filament printer, and those parts are printed in PLA with a 0.08 layer height. And they turned out, I would say, pretty good. Absolutely usable compared to resin parts. This small dragon is very, very detailed, and it's better to use a resin printer to make one. So I made two versions. One is highly detailed and one is a little bit simplified to make it print easier on FDM machines. Pre-supported files for resin prints are included in the download. Now let's talk about the guard. I decided to make a sticker for both sides of the guard because this design is quite intricate, and I thought just printing it and using a self-adhesive paper will be the best solution. I will still correct colors a little bit on the final version, but I really like how it turned out. So, to build the sword, you will need to print stickers for the guard, you will need some wrappings for the handle. I use two-part epoxy, two-part 5-minute epoxy glue to assemble my props usually. It does a great job and it's very stable in most conditions. Also, you will need aluminum tube, 8 millimeters in diameter and 72 centimeters in length. As we have a curved sword here, this metal insert, doesn't go all the way through the blade. It goes from the handle to... let me show you. It goes from the handle all the way up to here. And the last part of the blade is connected using a printed pin. In my experience, the most amount of stress when swinging a 3D printed sword is around guard or handle or where the blade starts. So having the last part of the blade on a printed pin is absolutely acceptable. The assembly is quite straightforward. This part on the handle was glued in place for the purpose of doing the wrappings, but there are two pins on the handle that will help align this part in place. And also there are designated space for Minuki parts on the handle too. Then this decorative piece just slides on the handle like this, and basically the handle is done. The guard, I will not disassemble this guard because the feet is quite snug there, but I will show you using my FDM test prints. So first we have this part, Habaki, also printed with 0.08 millimeter layer height. We take this, then one of those decorative pieces, and they are a bit different. As you can see, this one has kind of a step. So when you put it here, it locks in place. Then the guard. I suggest placing the guard here after you will apply the sticker. Then another one. And you can glue this assembly together like this. And then, when it's all done, this guard rim, it has a small step there. So when you, let me do it like this. So when you put it over, it snaps into place like that. And this is the guard. The blade, in addition to the aluminum tube, uses some printed pins so that the blade aligns perfectly when you assemble it. The scabbard pieces are quite straightforward too. Please focus. Please focus. So we have decorative pieces and we have this geometry on the scabbard that will help it put it in place and glue it there. And this part also comes off and it's supposed to be glued into. Between each other, parts of the scabbard are connected using this step that I made here, and they align pretty good there. There is a lot of free space inside of scabbard, so if you just put your sword inside, it will probably wobble and hit the walls on the inside. So usually I try to glue something, some fabric or felt or foam inside of the scabbard to make a better fit for the sword. And here I used, as you can see, self-adhesive felt. It's this is a thing used, for example, for some furniture door. Let me show you. So basically this. will you focus today? It's a bit hard to see, but I think you get the idea. I glued couple on the sides and one on top and bottom. Usually, to make a better fit for a sword, I do one area like this on the start of the scabbard and one closer to the end of the scabbard, or closer to the second part at least. So there are two parts inside that hold everything together. I've spent quite some time on this model, mostly figuring out how to make it look close to the source material while being a good usable prop sword, which is not easy sometimes. I think this will be the last 3D model by me from Devil May Cry 5. If you think that there are still some things that I haven't done that can be interesting and cool as 3D printable prop, let me know. You know where to find me. I will now assemble all of this and, like a 12-year-old, will play with the sword whole day and maybe probably record some short content video about it. But mostly I will play with it because I can. Anyway, good luck printing. I will see you around. Cheers. This needs to be glued.